আচ্ছা, লাস্ট যেটা পড়েছিলাম, before 2 weeks we had studied. The last lecture was on test on transformers. We were determining the equivalent circuit parameters of a transformer. So we had to perform two tests. One is your block rotor test, that is equivalent to your short circuit test on transformer, and another one was open circuit test on no load test. Okay, from there what we got the equivalent circuit parameters, and we could easily draw the equivalent circuit of induction motor. So from there, today what we'll do, we'll um, go on to starting methods. Okay, before going on to what are the different types of starting methods, we'll take a test on transformer. That is another test that is performed called polarity test. Now since it is a three-phase transformer, we had already done three-phase induction motor. We had already done three-phase transformer in our last semester, and we had taken a topic over there, that what will happen if there is a difference in polarity. Okay, so we had seen that if there was a difference in polarity, the voltage would have been unbalanced, and there are another problem also. You please go through that. So it is very important, if it is a three-phase machine, so polarity test should be done. Okay, otherwise it may lead to unbalanced voltage. For that, some circulating current will flow, many problems will come. So in three-phase induction motor also, we have to go for this polarity test. So one method of doing the polarity test is as told over here. So what we are doing over here is that, for one phase only, we have three phases, A, B and C. For only one phase, that is, suppose A, you may take it as B, you may take it as C, which one you want to take, no problem. You take only one phase, and to that one phase you give a supply V1. That is this is my stator side, so you are giving my supply to the stator. You give a supply voltage V1, single phase supply, not three phase supply. Since we are giving to one phase, so we'll give a single phase supply to A. Okay, so first point is, a single phase supply is given to A, and we will check that whether rated current is passed through it or not. We can attach an ammeter over here in series, and if I give a 440 volt, suppose 440 volt is given, we'll check what rated current is flown, and if that winding allows that rated current, then it is okay. If that is not allowed, then we'll reduce the voltage. Okay, so we'll give a single phase supply, that is rated voltage, to our one phase A, and we will mark the terminals A and B arbitrarily. Okay, so A1, and mark the terminals A1 and A2 like this. Anywhere you can mark this A2 as A1 also, A1 as A2 also, that is up to you. Okay, you mark these terminals arbitrarily. So my next point, mark the terminals of A arbitrarily as A1 and A2. Okay, A1 and A2. Now what we'll do, the next step, first we have given a voltage, single phase voltage to any phase. Then what we'll do, we'll mark the terminals of A as A1 and A2 arbitrarily, whichever you want to take it arbitrarily, you do it. Now one terminal, okay, one terminal of phase B, or of phase B, is connected to A2, right? One terminal of phase B is connected to A2 at this point. Obviously you know this is a neutral point of a star connection, and the other terminal of B, this is the other terminal of B, will be connected to the other terminal of A. Okay, over here it is A1, it is shown. So other terminal of B is connected to A1 through a voltmeter. So this is my connection. So first step is give a single phase voltage V1. Mark the second step is mark A arbitrarily as A1 and A2, whichever you want. And third step is connect a voltmeter between the other terminal. No, first connect one terminal of B with A2, and the other terminal of B will be connected to A1 through a voltmeter. That is the step. Now what will happen over here? Now if now this A and B, has a magnetic axis difference of 120-degree, we know, and also a supply will be given, that is 120-degree phase difference. We had done all this while checking doing how rotating magnetic field is done. So automatically this magnetic field between A and B is separated by 120 electrical degrees, and we have taken in terms of cos function. You can take in terms of sine also, no problem. So this A, if it is at cos 0, So if it is voltage is at cos 0, this will be at cos 120. Okay, so if A voltage is V1, then this B voltage will be at V1 plus V1 cos 120. Okay, that is what I want to say it. So that is what is written over here. The magnetic axis of A and B are displaced by space angle of 120 degree electrical, and the voltage induced in phase B by transformer action is V1 cos 120. Now, if this polarity, A polarity and B polarity, is relative to one another, what would become? Or if you can't understand what is relative to one another, think about this polarity markings over here. Suppose this A1 terminal is plus, this is minus. This B1. I'm marking this B arbitrarily again. This is B1 and B2. This B1 is plus, this is minus. What will happen? So if you apply KVL in this loop, okay, if you apply KVL in this loop in a clockwise direction, you will get plus VA. Right, this terminal is plus, this terminal is minus, I'm considering. So plus to minus, this voltmeter will show minus, so plus VA minus V, and then again goes in the clockwise direction, plus to minus, so minus VB. So this minus V goes on the right hand side, it will be VA minus VB. So what is VA? Is V1. What is VB? Is V1 cos 120. So V1 minus of V1 cos 120, it gives you 1.5 volts. Means 1.5 V1. Now, if suppose the terminals were opposite, this one, like this, that means this terminal was suppose B2 and this terminal is B1, all marked arbitrarily. Okay, we don't know which one is B1 or B2, but A1 is always positive and B1 is always positive. Okay, next. For this diagram, in transformer we had taken A2 as positive. We are talking in respect to this diagram only. So over here, one terminals means suffix 1 values are positive. So over here, suppose this terminal is positive, this terminal is negative, and this terminal is negative, this terminal is positive. So again apply KVL over here. What you will get? Plus VA minus this V plus VB. So this V will be VA plus VB. So what is VA? V1. What is VB? V1 cos 120. So add this two, it will come out to be 0.5 V1. So that's why when we can say, when this phase A polarity is relative to phase B, this A polarity is relative to phase B, then this voltage gets added, or this voltmeter shows a reading which is greater than the supply voltage. So that gives you 1.5 volt. Now, when this B is relative to A, that means at that time this voltmeter shows a value which is less than the supply voltage. By that you can understand how the polarities are present in A and B terminals according to the reading of the voltmeter, whether which phase is relative to which phase. That is, you can understand by taking the reading of the voltmeter. So that after that you can mark your polarities accordingly. So this is one type of test you can do to perform your understand what is the polarity of your induction motor stator windings. Now next method what you can do is, from this diagram you can see this A phase is completely isolated. Okay, first step we'll go follow by the steps. We'll mark this A, B and C arbitrarily as done accordingly. Wherever you want to mark A2, A1, you mark it accordingly. Okay, this is A2, this is A1, this is B2, B1, this is C2, C1, you mark it arbitrarily. So 6 terminal markings are done for A, B and C. 1, 2, 3, 4, 5, 6. Okay. Now what I was telling, that one phase should be kept isolated. Over here A phase is kept isolated. You can keep C phase also isolated, no problem. You can keep B phase also isolated. So one phase A is kept isolated and given a supply V1. Okay, like previous case A was given a supply. So again over here A is isolated and given a supply. And what happens for phases B and C? They are connected with each other and through a voltmeter, right? Their phases B and C are connected to each other through a voltmeter. Now how this connection is made? One terminal of B, that is I have taken B1 and C1, connected directly or short circuited between one another, and the other terminal, which is B2 and C2, are connected through a voltmeter. So that is written in third point. B1 and C1 are connected together and voltmeter is placed between B2 and C2. Now obviously you have to give a supply to a one phase. There's only the magnetic axis will come into operation, that cos 120, cos 240 will come into operation. Without a supply, nothing will happen. So you have to give a supply to A. So phase A is energized by giving a supply voltage V1. So what will happen to the voltage over here? So voltage over here will be V1 cos 120. Over here it will be V1 cos 240. So if you take the magnitude, I'm taking the magnitude without the signs. So cos 120 is 0.5 and cos 240 is also 0.5. So over here there will be 0.5 V1. Over here also there will be 0.5 V1. Okay. Now if you take this polarities over here, whatever plus minus sign is marked in this diagram, okay, and again apply KVL in this direction, okay, in the clockwise direction. So minus to plus I'm taking plus, then over here if it is plus to minus, then I'll take minus, and over here I'm not taking care of this voltage polarity, I'm going in this direction. So this is additive, minus to plus additive, and this is plus to minus gives a decremental value. So plus 0.5, this is minus 0.5, so this cancels out. So this voltmeter should show 0, right? So that's why it is written in fifth one, for the above figure the voltmeter should show a 0 reading, and hence the polarity of B and C marked are as follows. So the polarity of B and C, this side will be minus, this side will be plus, and this side will be plus, and this side will be minus for C. Okay, now if it happens in the opposite way, obviously it will get added. So you can see this is 0.5, this is 0.5, so 0.5 plus 0.5 gives you 1 times of your voltage. So if supply voltage is V1, so 1 V or 1 V1 or V1 it will give. So if this is the thing over here, this is also additive if you go in the clockwise direction, right? And if you go in the clockwise direction, this is also additive. 0.5 plus 0.5 gives you 1. So if you are getting a voltage, positive voltage, I'm taking the magnitude only. If you are getting a non-zero reading, that's why a non-zero reading is given. It can be negative also, because cos 240 and cos 120 have a negative value also. I've taken magnitudes. So this voltmeter, if shows a non-zero reading, that means this polarity is marked as follows in the diagram. If it shows at 0 reading, that means its polarity is marked like this. So this is how your polarity test can be performed, okay, on an induction. And it is very important to perform polarity test on 3-phase machines. Otherwise you will not know which terminal is positive and negative, and you will connect the supply positive to the negative terminal, then it will create imbalance of voltage and everything. Okay, so
এটার ডিসঅ্যাডভান্টেজটা কি আগেরটা আর এটার মধ্যে?
হ্যাঁ বল, আরেকবার বল।
এই দুটোর মধ্যে অ্যাডভান্টেজ আর ডিসঅ্যাডভান্টেজ কি আছে, মানে কম্পেয়ার করলে? একটা আইসোলেশন আর একটা
এখানে একটা কি মানে বি আর সি ফেজটা, মানে এখানে দেখ এ পুরো সার্কিটে মানে এই নিউট্রালটা ইউজ হচ্ছে, মানে কোথাও এখানে শর্ট হয়ে গেলে, ধরো সাপ্লাই দিয়ে শর্ট হয়ে গেলে, তাহলে বি ফেজ দিয়ে শর্ট হয়ে যেতে পারে। এবার পুরো সার্কিটটা যদি কানেক্টেড থাকে, এখানে যদি আমি কারেন্ট টেস্ট করি, একটা অ্যামিটার লাগাবো, অ্যামিটার থ্রু দিয়ে শর্ট হয়ে যাবে সার্কিটটা। কিন্তু এখানে মানে বি আর সি ফেজ আইসোলেটেড। যদি সাপ্লাইয়ে কিছু প্রবলেম হয়, ইফ দেয়ার ইজ আ প্রবলেম ইন সাপ্লাই, দিস পার্ট অফ দ্য সার্কিট মে বি সেভড। হ্যাঁ, কারণ আইসোলেটেড আছে পুরো সার্কিটটা, বি আর সি ফেজটা কোনো কানেকশন নেই। আমার মনে হয় ইট ক্যান বি অ্যাডভান্টেজ অফ দিস। আর থাকলে আমি ভাববো দিয়ে বলে দেবো, ঠিক আছে? Presently I'm thinking about this only because there is isolation between the phases over here. If there is a problem in supply, this A phase may get damaged, but B and C phase will not be affected so much. Over here, by the whole circuit is being used from A to B. We are using this whole circuit. If there is a problem over here and we want to measure a current over here also, it will short circuit this whole phase. Along with A, it will short circuit B. Now going into our main topic. Our main topic for today is what is starting in induction motor, starting of induction. Now you know what is the function of starter, because we have used a starter in a DC motor. It has helped to reduce the starting current, right? So over here also starter is used to reduce the starting current, and also it is all used for over voltage and under voltage protections also. Now what is happening over here? We have two types of rotor, right, in induction motor. One is your wound rotor induction motor, and one is your squirrel cage induction motor. In the squirrel wound rotor induction motor, what is happening? We can add additional resistance. So if I add additional resistance, it will reduce the current. So there is no problem over there. Okay, so that current can be reduced if we use a high resistance. Okay, if we go on increasing the resistance and slowly we cut down, as in a DC motor starter, what we do, slow at the starting there is high resistance, and slowly as the motor reaches the required speed, we can cut off that resistance and bring resistance to zero, so that normal current only flows. At starting we need high resistance, but in squirrel cage motor what will happen, there is no provision of adding additional resistance in the circuit, because you know the construction. Okay, there's a the conductors are at the end, there is end rings over there, copper bars are connected to end rings, so there is no provision of connecting resistance in order to limit the starting current. So what we'll do, what is the need of starting, we'll do first, and then we'll see into starting methods of squirrel cage induction motor, and next in a later class we'll see starting method of a wound rotor induction motor. And wound rotor induction motor, I told you how can that starting current be reduced, by using additional resistances in the rotor circuit. So my first point tells you that you already know from your torque slip characteristics, you know that there will be always a starting torque at slip equal to 1. That means at starting, when slip equal to 1, there will be a starting torque. And obviously induction motor, that's why induction motor is called as a self-starting motor. Okay. Now at starting, what happens when the induction motor is done at the starting, it behaves as a short circuited secondary, as you consider of a transformer. So a huge current flows at that time, so we have to bring a limit onto it, and that where starter comes into role. So there are two different types of starting methods of squirrel cage induction motor. Today our discussion, today and tomorrow, next day's lecture will be on discussion of starting of squirrel cage induction motor. Now in squirrel cage induction motor, we will have two different starting methods according to the supply voltage. So first is full voltage starting, and second one is reduced voltage starting. Okay, according to the name, you can understand that whatever, suppose we are giving a 440 volt supply, that means 440 volt is directly given to the stator mains. Now, according to reduced voltage supply, what will happen? We'll give some percentage of that 440 volt. Suppose we are giving some X percentage of 440 volt, maybe 400 volt will give, or maybe 330 volt will give, whatever we want we will give that. Okay, but we'll go through this in the latest. Okay, we'll go talk in detail about this in the later slides. In full voltage starting, we are classifying into direct online starting. Okay, from this name only you can understand direct online starting. That means stator is directly connected to the main supply. We are not keeping any intermediate circuit in between the stator and terminals and the supply mains to reduce the voltage. So we are directly connecting the stator to the supply. In reduced voltage starting, so there are three methods of reducing the voltage that is coming from the main supply and coming on to the stator. We can use a stator resistor or reactor in between the stator and the main supply. We can use an auto transformer. We can use star delta starting also. So this all these starting methods we have to discuss in detail and make a comparison between all these methods and see what is the advantage of dual starter and this stator resistor auto transformer or star delta starter. We'll go into this. Now, why a particular method should be chosen? It depends upon three factors. What is the size and design of the motor? What is the power capacity, what is the line capacity is given, and what type of loads we are going on to drive through the induction motor. There is one advantage, we have full voltage starting and reduced voltage starting. Now, if I give full voltage, suppose 440 volt, then the current will be according to that only. For 440 volt, 10 ampere current will flow. Okay, so for a very high voltage, a high current will flow. At the starting only, it may damage. So if that 10 ampere is not suitable for the stator windings, it may damage the windings insulation. Okay, so what we will do, we'll give a reduced voltage, we'll give a 330 volt. So that 10 ampere will not flow, maybe 6 ampere will flow. And if 6 ampere is within the limits of the stator winding rated current, then stator winding insulation will not get damaged. So that is one advantage of your reduced voltage starting. But there is also one disadvantage. Since induction motor needs a starting torque, at starting only, it is a self-starting motor. At starting there should be a torque present so that it starts automatically as soon as we give the supply. If you recall the facts of torque and voltage relationship, torque was directly proportional to voltage square. Now if you go on reducing the voltage, your torque will also reduce. Okay, so there is a chance if you take a voltage, if you go on reducing the voltage to a very low value, that starting torque will not be developed and induction motor will not start. So there should be a compromise made between the starting torque and the starting current in reduced voltage starting. Okay, so you can see that if I reduce the voltage, there is a provision my current will reduce. That means my starter is working correctly. My main function of the starter is not violating, it is reducing the current, but it will also reduce the torque. But if the torque is reduced to some very low value, that may be not sufficient enough to start the induction motor. So that is a problem of reduced voltage starting. But keeping that in mind, we have to make a compromise between starting torque and starting current in this reduced voltage starting. And most advantage is this, because at this, if you are giving a high voltage, if high current passes, there will be a damage. But if you make a compromise and keep the voltage at a certain range, then current can also be obtained at a range, and torque, starting torque can be also obtained at a particular range, and thereby starting can be easily possible. So reduced voltage starting is more preferred than full voltage starting. So that point is written over here. You can go through it. I have discussed in detail. We'll just go into how we are bringing about direct online starting. So when discussing about direct online starting, you can easily understand that if my motor is directly connected to mains. Okay, I think there is no this M and A auxiliary switches and main switches are here present. It is directly connected to mains. Think. Okay, I'll come to this later how this is used. So if I turn on this supply will be directly connected to this. Okay, directly connected to this motor, and there will be a starting torque and the motor gets started. And if this voltage is very high, there may be a high current also passing through. And by chance, if this whole circuit which is given on the left hand side, if fails to operate, there is a fuse given over here. Okay, if it exceeds a certain value, suppose last example we had taken 10 ampere and 9 ampere was the actual value over here. I'm taking ideal case. So if it is 10 ampere, okay, the fuse will get burned out. The material of the fuse will get burned out. So supply gets disconnected. So every protection should be given to her over here. So if this circuit on the left hand side fails, the fuse will operate and this will disconnect the supply from the motor. So what is done over here, we'll go into detail in 1 minute. Okay, just 1 second. So my first point in this method, the starting of squirrel cage motors, the motor is connected by means of starter across full supply voltage. That is what I have told just now. And obviously there is an inclusion of fuses to provide protection. Next, there is a coil over here. If you recall the facts of a starter in a DC motor, there were also some over voltage coils, some overcurrent relays. Right, over here also in the starter there is a presence. So there is a coil present C over here. Okay, and there is a start and stop button over here. Okay, this start button is always in off state. Okay, that means I can consider 0. Okay, so see, start button which is normally open by a spring, so it is always kept in off state. And this stop button is always kept in on state. Okay, this remote stop is that if you present in the remote location, you can use this remote stop to disconnect it from the supply. Okay, I'm thinking this is not this is present, and since it is a stop button, S3 is always closed. So this S2 and S3 are always in closed state. Okay, normally closed state, and a start button is normally open state. Now what happens? Now when this start button S1 is pushed, this you are pushing this start button S1. Okay, this is also pushed down. This is a another protection which will disconnect it if there is a overcurrent over here. So this is also pressed. So S2, S3 and D is on. Now we are pressing this button start. Okay, now if this start button is pressed, okay, this point of the C is connected to L1, right? Now if this start button is pressed, this L2, this point of C, the other terminal of the C gets connected through this stop button, because stop buttons is normally closed through this L2. So that's why when your start button S1 is pressed, your contactor C, this coil C, is energized through which lines? L1 and L2. Okay, now this L1 and L2 gets connected to the two ends of this gets energized. Okay, now this part of this is connected to A, and this part is S1 is S1, this point is connected to B. So all these points are energized. So this A and B closes, this auxiliary switches closes. As this energized, this will pull this in this side. So this contacts A will come in this side, and this will close this point AB. So auxiliary coil, this A means auxiliary, okay, and M means mains. So this auxiliary coil M gets closed. So the three main contacts M and auxiliary contacts A gets closed, and terminals A and B are short circuited. So if this main terminals are closed, so directly L1 is connected to motor, L2 is connected to another phase, L3 is connected to another phase. So this three-phase supply gets connected to the motor. Okay. Now, when this pressure is released over here, when the start button pressure is released, that means it is pulled back. It is operating in terms of spring action. Once it is pushed, it will close. Once it is pulled back, it will open. So this C gets disconnected from this L2, right? So this coil gets disenergized or de-energized. Okay, now if this coil gets de-energized, sorry, one second.
না না, ওই এবি পাতটা দিয়ে তো যাবে, এনার্জাইজই থাকবে।
হ্যাঁ 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 হ্যাঁ, একদম একদম একদম, ওটাই ওটাই। এই যে সরি ডি এনার্জাইজ হয়নি, এই স্টার্ট বাটনটা জাস্ট ওপেন করে দিলাম। হ্যাঁ, এই স্টার্ট বাটনটা জাস্ট ওপেন করে দিলাম, এটা কন্ট্যাক্টে আছে অলরেডি, ঠিক আছে। দিস কয়েল সি will be energized through this AB contact. এই AB contacted through, it will still remain energized, and the motor will get supplied from this mains. Okay, in order to disconnect this, okay, in order to disconnect this, একটা second,
মেনটা কি অফ করে দিলেই তার মোটরে পাওয়ার যাবে না?
হ্যাঁ, মেনটা তো অফ করে দিলে ওটা তো আলটিমেট সলিউশন না, মানে এই স্টার্টারের জাস্ট ফাংশনটা আমি ভাবছি। মেনটাকে অফ করে দিলে আলটিমেটলি পাওয়ার যাবে না। আমার প্রথমে এটাকে এনার্জাইজ করলাম, this contacts are getting connected and the supply is getting over here. So if this is released, it will move back under spring action, and
এটা দুভাবে ওই অফ করা যায়, একটা দুখানা স্প্রিং থাকে, মানে ওই S2 টা রিমোটটা দিয়ে স্প্রিং।
তাহলে হ্যাঁ, তাহলে আইদার আমাকে এই S2 বা S3 কে ওপেন করতে হবে, তাই তো? তাহলে এই S2 বা S3 কে ওপেন করতে হবে, কিন্তু S1 যদি ডিসকানেক্টেড হয়ে যায়। আচ্ছা 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 আচ্ছা, বুঝতে পেরেছি, সরি, একদম একদম ক্লিয়ার হয়ে গেছে। আচ্ছা দেখো আন্ডারস্টুড, কনফিউশন হয়ে গেছিল এখানে, সরি। এই দেখো, ঠিক আছে, এইটা ওপেন করে দিলাম, আই এম ওপেনিং দিস স্টার্ট বাটন। হ্যাঁ, স্টিল দিস ইজ এনার্জাইজড। কেন? দেখো L1 তো এখান দিয়ে কানেক্টেড আছে সি পয়েন্টের এখানে, L2 টাও দেখো এই S2 এর মধ্যে দিয়ে it is connected through this S2, S3, this D point and this one B, right? If this is open, if I am bringing back this start button by pushing this start button and making it off, this C is energized even because this C is connected to the coil. One side is connected to L1 and another side is connected to L2 through S2, S3, D and this B point. So obviously this C is energized through this AB point, right? তাহলে এই যে auxiliary and main contacts will be closed and supply will come to the motor. I think everybody understood. Now in order to disconnect this supply, how this C is being energized now? Through this auxiliary coil, means auxiliary contact A. Now I need to disconnect this B point, so I can open this stop button, means which is normally held closed. I'll make it open. So if this is open, there will be no contact of this L2 to this A. So if there is no contact over here, this will be de-energized. This coil will be de-energized and this auxiliary and main contacts will open. And if this is open, no supply will be to the motor. So this is how the operation is done. I think everybody has understood this. Sorry for the confusion.
স্যার স্টার্টটা তাহলে স্টার্ট যে বাটনটা ওইটার তাহলে কাজটা কি হলো?
ফার্স্ট স্ট্রোকটা দেয় কারেন্ট সাপ্লাই এনার্জাইজ করতে লাগে সিটাকে।
আচ্ছা এইখান দিয়ে তো তুমি বলছো এইখান দিয়ে
এটাকে
যদি
এনার্জাইজ
এনার্জাইজ
করতে একটু সুইচ দিয়ে, মানে বন্ধ থাকলে L1 দিয়ে
মানে
ফ্লো করছে,
এবি টার্মিনাল দুটোর বদলে আমি যদি শুধু স্টার্টটাকে ইউজ করতাম তাহলেই তো তাহলে এখানে হয়ে যেত।
আরেকবার কি
এবিটা যদি না থাকতো,
হ্যাঁ
দিয়ে আমি যদি স্টার্টটাকে দিয়ে কন্ট্রোল করতাম,
হ্যাঁ স্টার্টটা দিয়ে কন্ট্রোল করতে হয়ে যেত, কিন্তু যদি এটা ওপেন থাকতো তখন তো মানে এবি টার্মিনালে
মানে
আমার
ফার্স্টে S2 টাও শর্ট সার্কিট আছে, স্টার্টটাও শর্ট সার্কিট, তখন ওটা এনার্জাইজ হলো। তারপরে যখন S2 টাকে ডিসকানেক্ট করে দিলাম তখন ওটা ডি এনার্জাইজ হওয়া স্টার্ট করে দিল।
হ্যাঁ ডি এনার্জাইজ স্টার্ট না, তখন ও এনার্জাইজ থাকলো, মানে মানে স্টার্টটাকে S1টাকে আমি ওপেন করলাম তখনও এনার্জাইজ থাকছে এবি থ্রু দিয়ে, কারণ এবি থ্রু দিয়ে কানেকশনটা কমপ্লিট হয়ে যাচ্ছে।
আমি এবিটা বলছি যদি না থাকে শুধু স্টার্টটাকে ইউজ করি,
স্টার্টটাকে ইউজ করলে দেখো এটা এখান থেকে এটা কানেক্টেড হলো, এখান থেকে এটা শর্ট হয়ে গেল, কোনো প্রবলেম নেই, ডাইরেক্ট L2 এর সাথে কানেক্টেড। কিন্তু যদি এটা ওপেন করে দাও তাহলে তো এটা অটোমেটিক্যালি আচ্ছা তুমি বলছো এটা অটোমেটিক্যালি ডি এনার্জাইজ হয়ে যাবে। হ্যাঁ ঠিক আছে, কোনো অসুবিধা নেই, ইট ক্যান বি আ প্রবলেম, আই থিংক সো। If I open this, then there will be no contact between L2 over here. Okay, L2 সঙ্গে কোনো contact নেই, তাহলে there it can be de-energized over here. I think মানে there is মানে in a construction there is always a start and stop button over there. মানে ডল স্টার্টার তোমার হ্যাঁ বলো।
হ্যাঁ স্যার বলছি, আমি মানব বলছি স্যার, আমাদের ওয়াইফাইটা খুব ডিস্টার্ব করছে বুঝলেন তো, ওই জন্যই মানে বারবার কানেক্টিং রিকানেক্টিং এরকম হচ্ছে।
হ্যাঁ ঠিক আছে, কোনো অসুবিধা নেই,
হ্যাঁ বললাম।
হ্যাঁ আমার মনে হয় ওইটাই হবে, মানে মনে হয় যে কোনো ডল স্টার্টারে দে গিভ আ স্টার্ট এন্ড স্টপ বাটন, নো প্রবলেম, বাট I think you can utilize without a start button. This stop button can be thought as a মানে একটা বাটনই can be thought as start and stop. One button can also be thought as start and stop. এটা ক্লোজ করে দিলে সার্কিট ক্লোজ, এটা ওপেন করে দিলে সার্কিট ওপেন, it can be thought like that also. Yes, no problem for that. আমার মনে হয় ডিসি মোটরে যখন স্টার্টিং করেছিলাম একটাই বাটন ছিল, ওটা পুশ করে দিয়েছিলাম দিয়ে অন হয়েছিল, তারপর ওটাই যখন অফ করে দিয়েছিলাম তখন ওটা ওপেন হয়ে গেছিল, তখন ক্লোজ হয়ে গেছে। So that's not a problem, I guess. These are some of the points written over here. You just go through it. What will happen if I take a doll starter and all? Because it is directly connected to mains, it will take 5 to 7 times of full load current, and that's why we have to go for reduced voltage starting, and everything is written over here. You just go through it. Okay, I'm not going into detail about this. And one problem over there is because of this large currents, okay, because of this large current, there will be a supply voltage drop. Okay, undesirable dip in the supply line voltage. Induction motor টাই অনেকটা voltage যদি power নিয়ে নেয়, তাহলে supply অনেক drop চলে আসবে। বাকি যা devices, all the devices that are connected to this supply, same supply is given to the, suppose a tube light, suppose a fan, and also the induction motor. Induction motor, if drags all the power from it at starting only, if a large voltage is given and starting on, there will be means lighted যে পাওয়ারটা দরকার হয়তো কমে গেল, ঠিক আছে, লাইটটা it will dim, so it will cause okay. So what I was telling, that because of that huge power will be drawn by the induction motor itself, it will cause an undesirable dip in the supply line voltage, and all the equipments that is connected to the same supply only may be affected. Okay, so that's one of the problem of this direct voltage starting, and obviously the current is also very high. So what we'll do is next study the torque equations, and then this torque equations will be compared with reduced voltage starting, how that torque is affected, how that current is also affected. We have to compare this DOL starting, direct online starting, with reduced voltage starting and take it. Okay, from this also we have many problems. Okay, problems also come for this equation. So what do we know of our torque? Torque equation, we know general formula is 1 by omega s is I2 square R2 by s. Okay, now at starting what is happening? This s is 1, so TEST is nothing but I2ST, my starting current, square R2 by 1. At full load what will happen? Obviously my current will be full load, so I2FL square R2 by SFL. Now this R2 cancels out, and this is a square term of current, so I2ST square by I2FL square into SFL. You know the symbols have what meaning is that, so I have not written it anywhere. If no load current is neglected, since no load current is very small, we know we will neglect that, and we'll try to balance our MMF as we had done in transformer. So the primary side MMF will be equal to secondary side MMF, or the stator side MMF will be equal to rotor side MMF. So IST on the stator side multiplied by effective stator turns, which is the MMF on the stator side, N into I, and N into I on the secondary side will be I2ST, 2 means rotor, okay, into effective rotor turns. So IST can be written as I2ST, and we have stator turns brought in this right hand side, so rotor turns by stator turns, that gives you N2 by N1, which is nothing but turns ratio. So that's why it is written effective rotor to stator turns ratio. Now if I write in terms of full load, so current on the primary side is directly proportional to your current on the secondary side. So if I write IF in terms of IFL also, so what I can write, IFL is equal to I2FL into effective rotor to stator turns ratio. So we have written in that only and divided the two. Okay, so I2ST into that turns ratio by I2FL into turns ratio. So instead of IST, so IST over here can be written, IST by IFL can be written as I2ST by I2FL. So this I2ST over here, instead of writing on the rotor side, we can write in terms of stator side, because the voltage, full voltage is applied to the stator. So I can replace this I2ST in terms of IST also. So IST by IFL, where IST is your starting current, IFL is your full load current. So starting torque by full load torque is starting current by full load current whole square into SFL. This is a very important equation, which you will require to compare with other torques developed in reduced voltage starting, as well as will require in problems also. So remember this equation very nicely. Okay, very important. Now since at the starting we know that the induction motor behaves secondary short circuited, you know, and we are neglecting this parallel branch, because it over here the no load current flows, we are neglecting the no load current. So this parallel branch can be neglected, and starting S is equal to 1. So R1 plus R2 plus JX1 plus X2 will be your ZS, short circuit. The secondary acts as short circuit, so we are representing it as ZSC. So ZSC. What will be the current flowing in the circuit? So that will be ISC. Instead of I1, I will write ISC. What is the voltage? V1. V1 divided by impedance of the circuit. What is the impedance? Just now we have told. So ZS. Now at starting, this is a starting current only, because at starting your slip is 1 and this behaves as a short circuit. So this IST is nothing but ISC. So IST is equal to ISC is equal to V1 by ZS. And similarly, this IST can be replaced as short circuit current also. So instead of IST, we have written ISC by IFL whole square. So you can remember this equation is very important. Instead of remembering this equation number 2, I'll say you remember this equation, because sometimes in question they may say in terms of short circuit current. That is nothing but your starting current. Okay, and full load current you have to calculate it. That is, or this ratio will be given. Next, we'll go into your last topic for today. We'll go into your reduced voltage starting. What is happening in reduced voltage starting? Now, according to the name only, you can understand that we are reducing the voltage. So at a start, if the voltage gets reduced, our current will also get reduced, because at the starting this impedance is constant, no problem. This V1 gets reduced. So if V1 gets reduced, okay, V1 gets reduced, so ISC will get reduced, and ISC is equal to IST. So starting current will also reduce. So that is what we want to implement over here. So what we will do, in between the supply, this side is the supply. Behind this dot, we are giving a supply, and this is our stator, which is connected in star. We are connecting a reactor over here, or a resistor, means rheostat. We can use a rheostat or we can use a reactor. So a reactor or a resistor is inserted between the motor terminals and the supply lines. So between the supply over here and the stator terminals over here, we are connecting a reactor or a rheostat. So you know, using rheostat we can change the variable resistance, and if the resistance is to the max, if it is taken maximum, then if this is V1, whole V1 will be applied over here. If this is some X of V1, if we control the voltage, if we get a X V1 drop over here, so we'll get X V1 over here also. Okay. So you can see from the diagram, I'll come to this points after explaining. So if you are taking the whole, if you are taking the maximum value of this means rheostat, okay, so the whole voltage appearing over here across the stator terminal will be V1. Okay, so this will be V1. Yes, Arush, you can ask any doubt if you have, no problem. Okay, so this is V1 over here, whole voltage. Now, if you are taking certain percentage of this reactor, okay, so what will be the voltage? X V1, and V1 is the line voltage. Okay, this is the line voltage. So X V1 will be the line voltage if you are taking certain percentage over here. And if you write in terms of phase voltage, what you will get is root 3 V1, because it is a star connection. VL equal to root 3 VPH. Okay, sorry, V1 is your phase voltage over here. So V1 over here, and the other phase voltage will be X V1. These are two line points. So measured, if I connect a voltmeter over here, I'll get line voltage only. And voltage between this line and neutral is phase voltage. So see, this is X V1, phase voltage over here. So this is a V1 is your phase voltage, and VL equal to root 3 VPH for star connection. So root 3 V1 at the supply. And if I time X times over here, so this will be root 3x V1. So that is what we have written over here. At this time of starting, some voltage drop will occur across the starting resistor or reactor, and thereby only a fraction X of the supply voltage appears across the stator terminals. This is what happens. Now, as the motor starts reaching full load, means as the motor starts reaching its original speed at full load, you can cut off this reactor. Okay, you can make this reactor value 0, so that normal current flows. At starting, we have to limit the current, so you can take this as maximum value. Okay, and at the normal running condition, you can reduce it to 0, so that normal rated current flows. So this is one of the mechanism behind the resistor or reactor starting. Okay, so last slide for today. What is happening? We will understand the torque and voltage also. So just now, as I was stating, what will be IST now? My voltage has become X times V1. So X V1 ZSC. So what is V1 by ZSC is nothing but your short circuit current ISC. So now this becomes X of ISC over here. Okay. Now what is my starting current? Just now we have done the relationship. That's why I have told you to remember this one. So TEST by TFL equal to IST by IFL whole square into SFL. This is a standard value. So that value I have written over here. So what is IST is nothing but your X ISC substituting over here. So this becomes X square IS. Now X can be 1 or less than 1. It can't be more than 1 because it is a fraction. So at maximum it can be 1, and less than 1 if I take, so 0.8. Okay, so 0.8 square gives you 0.64, and if this is ISC square, 10 square, so 100, 0.64 into 100. So it will reduce the value of short circuit current. Okay, so current is getting reduced. Short circuit current is 100 ampere. Now with this starting, we are getting x square of this short circuit current. Okay, ISC square. So we are getting a reduced value of short circuit current. And what happens to the voltage? Now starting torque with reactor starting, we know torque is directly proportional to voltage square. Please go through the previous lectures. We had already done this. T is directly proportional to voltage square. So torque with reactor starting, what is the voltage over here? XV1, right? So XV1. So starting torque with direct starting, what was our voltage? V1. So this V1 square cancels out, this becomes X square. So X square times torque of direct starting. So there is a compromise of the torque done over here, you can see. So X square is 0.8 and 0.64 into direct switching torque is 100. So 0.64 into 100, it reduces the torque. It reduces the current, which is very essential. It reduces the starting torque also, but we have to take care that the starting torque is not reduced to some minimum value that that starting torque will be not utilized in starting the motor. So compromise has to be done. So X should be chosen in such a way that starting torque is having a sufficient value in order to start the motor. So there is a compromise that has to be made. So it is very important you should know these two formulas. And what happens, you know that reactor is basically your inductor, and variable inductors are very costly. Rheostats are very easy to find and very easily available and less costlier than variable inductors. So if you use a variable reactor, it will be little bit costly. But one advantage of using a reactor is that inductor losses are very less. Whatever the internal resistance of the wire will be there, losses will be that only. But if you take a series resistor over here, so losses will be very high. Okay, so take care of this. What are the advantages of using resistor and variable reactor, and why we are using a reduced voltage starting? Because we are reducing the current, very essential, but torque is also reduced, and a compromise has to be made between starting torque and starting current. So this is today's lecture. Next on Wednesday we'll continue with the other methods and some other topics. So if you have any doubt, you can ask me, or we'll conclude over here. এটা বেসিক্যালি সেমিস্টারে তোমাদের থিওরিটিক্যাল কোয়েশ্চেনই আসবে, ঠিক আছে? এক্সপ্লেন ডল স্টার্টার, সো ইউ হ্যাভ টু ড্র দিস ডায়াগ্রাম অ্যান্ড রাইট দিস পয়েন্ট। এটা তোমাদের ল্যাবেও ছিল, এক্সপেরিমেন্ট ল্যাব তো হচ্ছে না। তোমরা এক কাজ করতে পারো, ইউ ক্যান গো টু ভার্চুয়াল ল্যাবরেটরিজ, দেখবে many IITs, NITs and many colleges have created virtual laboratories. You can search on Google and check virtual laboratories, and over there they will get a list, and from there you can perform at home also those experiments which are given over there. Okay, jani na induction motor ache kina over there, but I had checked DC motor experiments were there, and the steps were also given. You can go through those steps, perform the experiment and understand how those operation is done. You can go through that, and if you see doll starting and all is there, induction motor characteristics, you can do those experiment in virtual laboratories also. You can search in Google and get that. That is your task of understanding it. Theoretical portion I can clear for you just now, and this theory, these things will come as theory. Explain polarity test. Any one method you just explain. Okay, check the marks. If it is asked 2 or 3 marks, maximum 3 to 5 marks will be asked. You have to write all these points. Or one method you can write this, or second method you can write this one. And you may ask either of the starting, it is dull starting or it is reduced voltage starting, and obviously you may be asked to solve problems using this formulas, which we'll later deal on Wednesday, I think. Okay, ঠিক আছে, তাহলে এন্ড করছি লেকচার।